Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good morning. All of you can see my screen and can hear my voice. Okay, so please put your name and class in the comment. Okay, so today we will continue with the new chapter, which is chapter 6, Thermochemistry. So this is chapter 9.1, concept of enthalpy. So at the end of this chapter, you will able to explain what is endothermic and exothermic reaction by using energy profile diagram, state the condition of a reaction, and define the following terms: enthalpy, standard enthalpy. Define and write the thermochemical equation for each enthalpy: formation, combustion, atomization, neutralization, and dissolution. So first, what is thermochemistry? Okay, today we will learn thermochemistry. So what is the thermochemistry? Okay, thermochemistry is the study thermo daripada thermo ialah perkataan yang relate with temperature. Okay, study of heat chain in a chemical reaction. So bila ada chemical reaction, dia mesti ada chemical equation. So in chemical reaction, the reactant and the product considered as a system. Okay, saya akan guna terms ini banyak kali. System is the specific part of the universe that is interest in the study. So surrounding is everything that lies outside the system. Surrounding tu yang luar daripada sistem. Okay, contoh sistem kalau kamu buat neutralization. Okay, sistem ialah between acid and base, and dia punya produk ialah salt and water. So surrounding tu contoh kat luar lah, tekanan, pressure, humidity, suhu, kelembapan, and so on. So we will learn what is open system, closed system, and isolated system. So open system is a system that can exchange the mass and energy with the surrounding. Satu sistem yang dapat dia boleh menukar, exchange jisim dan tenaga dengan surrounding. Okay, contoh. Okay, example adalah masa kita masak, cooking. So masa cooking is adalah open system sebab kita akan release water, air akan keluar, kita akan absorb gas and so on lah. So maksudnya ada. Okay, kalau closed system is system that allows the exchange of energy with its surrounding. So closed system adalah sistem yang membenarkan pertukaran tenaga dengan surrounding, tapi but not allowed to exchange the mass. Okay, ini contohnya, example, macam kalau kita tengok dalam, kalau kita pergi pasar, ada simpan ikan dalam polystyrene, so dan dia letakkan ais. So ikan dan ais tu ialah satu sistem, dia ialah isolated, di mana dia tak ada benarkan air tu tersejat keluar, tapi haba dalam tu dia boleh transfer. Okay, so isolated system is a system does not allow the exchange of either mass or energy with the surrounding. Sistem yang tak membenarkan pertukaran jisim ataupun tenaga dengan persekitaran. So there is a temperature difference between a system and its surrounding. Heat will be transferred from a region of higher temperature to the one with lower temperature. Okay, bila ada perubahan, bila ada perbezaan suhu, haba akan dipindahkan daripada suhu tinggi kepada suhu yang rendah. Okay, so once the temperature will become equal, so the heat flow stop. So bila suhu dah sama, so tindak balas tu akan berhenti. So kita kena pasti the identification of heat. Heat is defined as the energy transferred between two bodies of different temperature. Okay, heat ialah tenaga yang dipindahkan di antara dua bahan yang mempunyai suhu yang berbeza. So heat symbol as Q. So energy is the ability to do work. Okay, tenaga adalah kebolehan untuk melakukan kerja. So the unit for energy is calorie, okay, ataupun symbol as CAL. So 1 calorie will be equal to 4.184 joule. So okay, enthalpy H, enthalpy symbol as H. Okay, the definition is a quantity reflecting the energy content of a system at a constant pressure. So the absolute value of enthalpy of a system cannot be measured. Okay, enthalpy ialah menyatakan mengenai kuantiti perubahan tenaga bagi satu sistem pada tekanan yang tetap. Okey, nilai enthalpy yang actual tak dapat diketahui, okey, tak dapat dapat diukur, tapi kita boleh kira the enthalpy change, perubahan tenaga. So enthalpy change symbol as delta H. So enthalpy change can be measured by using the formula enthalpy of product minus enthalpy of reactant. Okay, so the energy change in a chemical reaction can be represented by energy profile diagram. There are two types of chemical reaction, whether the reaction is exothermic reaction ataupun endothermic reaction. Okay, so kita akan belajar energy profile diagram. So kita akan belajar energy profile diagram. Okay, so kita mesti tahu delta H ialah jumlah, okay, jumlah itu ialah summation H enthalpy of product minus summation of enthalpy of the reactant. Okay, so kita belajar dulu nak balas exothermic. Exothermic, the value of delta H, ciri dia yang pertama ialah the value of delta H is negative. Okay, example, delta H is negative 50 kilojoule contoh. So tindak balas exothermic maksudnya the energy is released to the surrounding. So since kamu kira delta H ialah enthalpy, jumlah enthalpy of product minus jumlah enthalpy of reactant, so delta H akan bernilai negatif if, okay, jumlah enthalpy of reactant will be larger than jumlah enthalpy of product. Okay, am I correct? Okay, nilai ini akan bernilai negatif kalau tenaga yang kat belakang ni lagi besar. So satu nilai tolak nilai yang besar, so nilai kat sini dapat negatif. So delta H reactant will be larger than enthalpy of product. So sekarang kita nak belajar lukis energy profile diagram untuk exothermic reaction. Okay, untuk tindak balas exothermic. Okay, so ni energy is released to the system, to the surrounding. delta H negative I mentioned tadi. So this is the example. So this is a system. So the heat released to the surrounding. Tidak balas exothermic. Okay, so bawah tu energy, bawah tu ialah reaction progress. So nak lukis, so ini ialah energy, bawah ialah reaction progress. Okay, so on your left side, ini sebelah sini mesti reactant. So tenaga bagi reaktan lagi besar. So sini tenaga delta H bagi reaktan besar. So bila lagi besar lagi ke atas sebab sini kosong, 1, 2, 3. So maksudnya nilai ke atas ni besar. Tenaga bagi produk lagi kecil kat sini. So atas ni adalah reaktan, bawah ni adalah produk. So daripada reaktan ke produk dia akan melalui satu requirement activation energy. So ini ialah the value of EA, the minimum energy required for the reactant to initiate the to do the effective collision, to initiate the chemical reaction. So kat sini, so sebanyak ini adalah haba yang dibebaskan. So delta H is negative. So this is the energy profile diagram for exothermic reaction. So make sure at the end of the class you can draw the correct energy profile diagram as my drawing, macam lukisan saya ni. Okay, so EA is the activation energy. So kat sini delta H is the enthalpy change, to delta H negative. Okay, so example. So this one, so dia bagi satu chemical reaction, kemudian dia letak sini delta H is negative, maksudnya energy release. So dia letak sini the reactant, so this is the reactant. So reactant ialah C3H8 gas plus 5O2 gas. So it's activation energy. So the product is 3CO2 gas plus 4H2O. So this reaction release energy as much as 2044. So dia letak kat sini delta H release negative 2044. Okay. Okay, so now we want to learn the criteria for endothermic reaction. Okay, so for endothermic reaction, so we will find that delta H, the value for delta H is positive. Okay, example, delta H is positive 20 kilojoule. So tanda positif ni menunjukkan the energy is absorbed. So the tanda positif menunjukkan the energy is absorbed from the surrounding. Okay, so since the value for, we calculate the value for delta H is summation of enthalpy of product minus summation of enthalpy of reactant. So the value of delta H will be positive, nilai kat sini positif, if the summation of enthalpy of product is larger than summation enthalpy of a reactant. Okay, so if we draw the energy profile diagram for endothermic reaction, so this is energy. So this is the reaction progress. So dia kata atas sebelah sini left side mesti reactant, so right side ialah product. So dia kata enthalpy of product is higher, reactant is lower. So reactant dekat bawah, product dekat atas. So this is the reactant. This is a product. So from reactant to product, dia akan need some activation energy, EA. Okay, in producing reactant to product, so this reaction need to absorb the energy from the surrounding as much as positive. Okay, so this diagram show that the heat is absorbed to the system. Okay, this diagram show as mine macam saya punya. So example, this is the endothermic reaction. So carbon plus hydrogen produce C2H2 gas, produce delta H positive 211 kilojoule. So C carbon and hydrogen is your reactant. C2H2 is your product. So since this is tindak balas endo, the energy of product will be higher than energy of reactant. So reactant kat bawah kan. So dia kat bawah, produk kat atas. So diagram mesti macam ni. So this one need as much as EA activation energy. This reaction will need to absorb the energy from the surrounding as much as positive 211. So label kat sini delta H positive. Okay, so we will do some tutorial question related with the what we have learned just now. So please refer your tutorial question on page SK1, question number 1. Consider the following reaction: hydrogen plus oxygen producing H2O. Question number 1, sketch the energy profile diagram for the above reaction. So this reaction is release as much as negative 2 for 1.8 kilojoule. So this reaction is exothermic reaction. So let's sketch the energy profile diagram. Question number 1A. So tutorial question number 1A. So the reaction is between, so the first the reaction is exothermic reaction. So maksudnya delta H is negative. Delta H is summation of enthalpy of product minus summation enthalpy of reactant. So since the value of delta H is negative, maksudnya jumlah enthalpy of reactant will be larger than summation enthalpy of product. So dia bagi, so H2O2 is your reactant, H2O is your product. So sekarang kita lukislah. So this one is energy, this one is reaction progress. Okay, so enthalpy of reactant will be higher dekat atas. So product will be lower. So your reactant is H2O2, H2 gas plus half oxygen gas, producing H2O liquid. Okay, This is symbol as EA, activation energy. So this reaction will release heat to the surrounding as much as delta H is negative 241.8 kilojoule. Negative 241.8 kilojoule. So this is the answer for tutorial question number 1A. Okay, can all of you understand to this lesson? Okay, we continue with question number 1B. Which enthalpy is larger? That is the reactant or product. Number 1B, the answer is, so saya dah tulis kat sini, number 1B. So the answer is and enthalpy of a reactant. Okay, number 1C. Okay, number 1C, for this reaction, what is the enthalpy change under the same condition? Okay, ni kita belajar lagi. Okay, so enthalpy of reaction. Enthalpy of reaction delta H is the enthalpy change associated with the chemical reaction. So standard enthalpy symbol as delta H naught. Tanda naught ni merefer pada standard. So what is the mean by standard? Means that the reaction is measured at the standard condition. So what is the standard condition? Standard condition is temperature at 25 degrees or 298 Kelvin. Pressure will be equal to 1 atm. Concentration of the solution is 1 molar. Okay, for thermochemical equation, now we will learn the thermochemical equation. Thermochemical equation is a balanced chemical equation that show the enthalpy change of a chemical reaction. Okay, yang satu tindak balas yang persamaan kimia yang seimbang yang menunjukkan perubahan enthalpy, perubahan tenaga bagi satu tindak balas kimia. So the thermochemical equation must include the physical state of the product and reactant and the enthalpy change delta H for the reaction. So this is the example for the thermochemical equation. So our objective is at the end of the class, make sure you can first understand what is thermochemical equation. You can write the correct thermochemical equation. So because why? Because the thermochemical equation is not given during the examination and you need to derive the thermochemical equation. So example, CH4 react with oxygen, methane undergo combustion with oxygen, produce carbon dioxide and H2O. So this reaction will release the energy as much as negative 890 kilojoule. So please refer this equation. So equation ni phase included, energy change delta H ni pun included. So the reaction ni dia bukannya tanda not maksudnya dia tak lakukan at the standard condition. Okay, so when the thermochemical is reverse, kalau tindak balas kimia tu dibalikkan, so the value of delta H also reverse. So example, so this is the reaction of methane, negative 890 kilojoule. If the carbon dioxide and water combine and reproduce methane and oxygen, so dia punya equation is same, cuma reverse saja. So the value of kat sini daripada energy release to the surrounding, energy will be absorbed to the surrounding. So this one memang of course lah energy absorb sebab ini adalah tindak balas yang first ni adalah tindak balas combustion. Pembakaran memang tindak balas energy release to the surrounding. Second reaction is tindak balas formation. Tindak balas pembentukan. So tindak balas formation dia ada involve form covalent bond. So tidak balas form covalent bond ialah dia menyebabkan delta H dia jadi positif. So when both side of the equation is multiplied by a factor n, so the value of delta H for the new equation must change by the same factor n. For example, CH4 react with oxygen, produce CO2H2O. So dia punya energy release is 890 kilojoule. So if CH4 kat sini ada 2 mole, so this one pun 2 times 2. So this equation, second equation ni ialah times 2. So maksudnya the value for delta H also times 2. Okay. Exercises, answer. Okay, type of enthalpy. Kita pergi pada yang soalan tutorial tadi. So kita dah boleh bincang. So for the reaction, what is the enthalpy change under the same condition? So we need to compare this one with this one. Okay, so kalau saya salin H2I2 C H2 gas plus half oxygen gas produce H2O liquid. So the value of delta H is negative 2 for 1.8 kilojoule, 2 for 1.8 kilojoule. So the second equation is 2H2 liquid, 2H2O liquid dissociate producing 2H2 gas plus O2 gas. So they ask you to find the value for delta H kat sini. So when you compare the first equation and the second equation, so first equation, second equation, so kamu akan dapati second equation is, so kamu akan dapati the second equation is reverse first equation and then times 2. Okay, betul? Okay, so therefore the value for delta H for second equation will be, okay, so kalau dia first equation reverse, jadi daripada 2 for 1.8 jadi positive 2 for 1.8 kilojoule, kemudian times 2, kemudian darab dengan 2, so you will get the value is, so what is the value? For 83.6. Okay, now we will study about the type of enthalpy. So okay, now we will study the type of enthalpy. Okay, so there are many kind of enthalpy, okay, such as enthalpy of formation, enthalpy of combustion, enthalpy of atomization, enthalpy of neutralization, enthalpy of hydration, enthalpy of solution. So all these enthalpy you need to remember the definition and make sure you can write the thermochemical equation based on the definition. So please keep in mind if the condition are at the standard condition, which is the pressure is 180 m, temperature 298 Kelvin, the enthalpy is called as the standard enthalpy of reaction. So standard enthalpy of reaction symbol as delta H naught. Okay, so first we will learn what is the enthalpy of formation, symbol as delta HF. F is for formation. Okay, so the heat change when 1 mole of a compound is formed from its element in their stable state under the stated temperature and pressure. So an example, delta HF for H2O. Okay, so the thermochemical equation will be, okay, this thermochemical equation will be okay, H2 gas plus oxygen plus H2 gas. So delta HF is -2 for 1 kilojoule. So ini dia dah bagi. So letak kat sini negatif. So kat sini kilojoule per mole. So since this reaction in 1 mole, so kita letak sini kilojoule je. Tak perlu letak kilojoule per mole. Okay, so standard enthalpy of formation, symbol as delta HF naught, is the heat change when 1 mole of a compound is formed from its element in their stable state at 180 m and 298 198 Kelvin. So example, the delta H dot F for H2O is -286 kilojoule per mole at standard condition. So the thermochemical equation sama exactly, cuma sebab dia dah cakap sini at standard, mesti ada simbol dalam delta H not F. Okay, exercise. So kita tengok soalan tutorial. So this one is done. So kita tak belajar lagi combustion. Tengok soalan mereka. Okay, tak ada juga. Okay, so exercise, saya ajar exercise ni. Okay, exercise. Write the thermochemical equation based on the following abbreviation. So dia dah bagi kat sini delta H not F, SO2. Okay, F is formation. So definition of formation ialah, ni definition formation of the heat change. Heat change tu dia boleh positive or negative, depends on the reaction, when 1 mole of compound so dalam kes ni compound dia apa, SO2 ataupun C6H12O6 is formed from its element. So kat sini ada tanda not kat sini. Ni ada tanda not, maksudnya at standard condition, which is pressure equal to 180 m and temperature is 298 Kelvin. Okay, so macam mana nak buat ni? Okay, sekarang ni, okay, perhatikan macam mana saya buat ataupun lukis, tulis persamaan kimia. So dia ialah SO2. So untuk formation, kamu kena buat daripada belakang. Compound kamu ialah SO2. Okay, betul? SO2 gas. SO2 gas. Okay, this is your compound. Okay, definition, the heat change when 1 mole of compound. So sekarang ni, this is compound. How many mole? 1 mole. Is formed from its element. So what is element that form SO2? The element that form of SO2 is sulfur. Okay, element sulfur is in the solid phase. Okay, so apa lagi elemen form SO2? oxygen plus oxygen O2 in the gas phase. Okay, kalau kamu tanya macam mana medium tahu sulfur is in the solid phase, oxygen is in the gas phase. So itu ialah elemen tu, maksudnya at the most stable state. Okay, so this is the compound. Kalau nak buat delta H formation, kamu kena buat daripada belakang ke depan. So this is the element at stable condition. So kamu kena hafal lah. So sulfur dia ialah considered as metal sebab dia ialah solid. Okay. So kat sini one sulfur, oxygen 2. So delta HF. So given in the question, delta HF not ialah 298. So tulislah delta H not F ialah negative 296.1 kilojoule. Okay, yang kedua. This is number 1. Okay, number 2. Okay. Write the thermochemical equation for C6H12O6 for delta enthalpy of formation. Okay, enthalpy of formation. Enthalpy of formation, ikut definition, the heat change, so delta H not formation. Okay, delta H not formation, the heat change as much as how many? Negative 1258 kilojoule. Negative 1258 kilojoule. The heat change when 1 mole of compound. So what is your compound? Your compound is C6H12O6. C6H12O6. So this is your compound. Compound ni mesti 1 mole. Kenapa mesti 1 mole? Sebab definition dia, the heat change when 1 mole of compound. Mesti 1 mole. So sini 1 mole tak? 1 mole. Form from its element. So what element producing C6H12O6? So this is sugar. The element is carbon, lagi hydrogen, lagi oxygen. So this is the element. So carbon, the most stable state is in the solid form. Hydrogen is the most stable state is in gas form. Oxygen is the most stable state is also in a gas form. So this is all the element. Okay, so C carbon ada 6 kat sini, so kamu letak sini 6. Hydrogen sini ada 12, so letak sini 6 times 2 is 12. Oxygen ada 6, so letak sini 3. So, yang mana mesti 1 mol? Yang compound, yang hujung ni mesti 1 mol. Kenapa compound ni mesti 1 mol? Sebab dia based on definition. Definition, delta H not formation is the heat change. Banyak kali saya mention ni, maksudnya kamu kena hafal definition ni. When 1 mole of compound, so compound ni mesti 1 mole. Kenapa saya very stresskan ini? Sebab nanti masa kamu buat Hess's law, kamu nak buat energy cycle, kalau kamu tak hafal definition ni, kamu akan ada masalah yang besar. So the heat change when 1 mole of compound form from its element at the, sebab dia ada tanda not kat sini, at the standard condition, pressure 1 atm and temperature is 298 Kelvin. So kita baru belajar the first type of enthalpy, which is enthalpy of formation. So the standard enthalpy of formation of any element is most stable state, which is the form is 0. Okay, macam saya cakap lah, the most stable state for oxygen is O2 gas, which is the formation is 0. The most stable state for sodium, bila dia stable, enthalpy of formation dia 0. Sodium at the most stable state is in solid. Chlorine in the gas, bromine in the liquid. So enthalpy of formation dia is 0. 0 tu paling stable lah. Kalau dia punya enthalpy formation dia ada nilai, maksudnya dia not at the stable state. So enthalpy of formation can be used to calculate the enthalpy of reaction. So delta H ni ialah enthalpy of reaction is delta H naught formation of product minus delta H naught formation of reactant. Okay, so exercise. Okay, so given is, this one is given, using the data given, calculate the enthalpy of the following for the reaction. So for the reaction, kamu ada left side is your reactant, okay, right side is your product. So macam ni. So kamu nak kira delta H. So kamu nak kira delta H, ini ialah enthalpy change. So enthalpy change delta H adalah jumlah enthalpy produk minus jumlah enthalpy reactant. So enthalpy produk ialah, okay, enthalpy of, kat sini dia bagi enthalpy of produk kamu ialah CO2. Ni ialah delta H formation untuk CO2 plus, so sini mana ada CO2, ada H2O, okay, plus delta H formation untuk H2O. Okay, so ini ialah untuk produk minus jumlah enthalpy untuk reactant. So reactant kamu ada C6H12O6, C6H12O6 plus delta H formation. So kamu punya reactant ada oksigen O2. Okay, so masukkan nilai. So carbon dioxide. So carbon dioxide kat sini ialah 392 kilojoule per mole. Per mole maksudnya for 1 mole. So kat sini carbon dioxide ada berapa? Carbon dioxide ada 6 mole. So sebab itulah kena times 6. So ini carbon dioxide ada 6 mole, sebab tu kena times 6. So same reason with H2O. H2O kat sini ada 6 mole. Given in the question is H2O ialah 286 kilojoule per mole, means untuk 1 mole. So kalau ada 6 mole, kena times 6. Okay, untuk oksigen kat sini ada 6 mole. So given for oksigen, okay. So apa trik dia kat sini for oksigen? Okay, oksigen kenapa dia 0? Ini ialah for oksigen. Ini ialah untuk oksigen. Sebab oksigen, the enthalpy of formation for oksigen, kenapa ialah 0? Sebab oksigen is an element, dia bukan compound. C6H12O6 adalah compound, CO2 adalah compound, H2O adalah compound. So oksigen adalah element, so dia punya enthalpy adalah 0. Sebab itulah keadaan yang paling stable bagi dia. Okay, so yang ni C6H12O6 So masukkan nilai, so you will get the value of delta H is negative 2810 kilojoule. Okay, so I think that's all for today. So we will continue discuss tutorial question next week. So thank you.